Dear students, welcome to the course Operating Systems. Myself, Tausif Naqshbandi from Department of Computer Science and Engineering, Islamic University of Science and Technology will be presenting third lecture of the course Operating Systems. In today's e-lecture, we will learn the properties of operating systems. Now, before discussing our today's e-lecture, that is properties associated with operating systems, we all should know what do you mean by property. Basically, a property is an attribute that is related with something. Now, let us take an example of a student. A student is an entity which is having some attributes. The attributes associated with the student are name of the student, date of birth of the student, registration number of the student, roll number of the student, address of the student. These are all attributes, or I can say the properties associated with the student. Same wise, we are having an operating system. An operating system is an entity which is having various properties. Now, the various properties associated with an operating system are: first one is batch processing, second one is multitasking, third one is multi-programming, fourth one is interactivity, fifth one is real-time systems, last one is distributed environment. Now, let us discuss all these one by one. First one is batch processing. Before learning batch processing, we all should know what do you mean by batch. A batch is the name given to the task of doing the same job over and over again. That means, in terms of a real-time example, I am a teacher, my job is to teach. I am doing this task again and again. Or let's take an example of an engineering college. Engineering college produces engineers each year. So, I can say that my job is to teach. I am doing this task again and again. So, the name given to this is a batch. Now, let us focus on the main point, that is batch processing. Basically, batch processing is a technique in which an operating system collects programs and data together in a batch before processing starts. This means that it is having the capability of an operating system which collects all the programs and data so that it can start processing. Now let us take a simple example over here in order to understand batch processing. For example, I have to print 1000 documents. Now there are two ways to print these documents. One way is to print each document by giving command again and again to print those documents. Another way is that I can process or I can print all these documents by a single command. Now what is the difference between the two? In the first one, there will be manual intervention. That means each time I have to give the print command. Now in the second one, I don't have to give any commands. That means that there will be no interaction by the user when the programs are being processed or when I am printing those documents. Now why these systems were introduced? Basically, these batch systems were introduced to reduce the computer CPU idle waiting time. What do you mean by waiting time? For example, waiting time means when I have to process something or when I have to print something, I don't want that my CPU will remain idle for that period of time. In order to get much efficiency, much response time from the systems, batch processors or batch processing was introduced. Now it is having the capability of an operating system which gives us such a power to process all these documents at the same time. Now the various activities associated with the batch processing are: first one is operating system defines a job which has predefined sequence of commands and programs and data as a single unit. Now how an operating system defines a job? It defines a job which is having some predefined sequence of commands. That means I should know what I have to do. This is predefined. This is to be done. The programs and the data, they are all kept together and put in a batch so that they can be processed. Second important activity is that operating system keeps a number of jobs in memory and executes them without any manual information. As I told you that number of jobs are kept in memory so that there will be no waiting time, CPU will not remain idle, and there will be no interaction by the user, or there will be no manual information, or there I can say that there will be no human intervention when the programs are being processed. Third important activity associated with batch processing is that jobs are processed in order of submission. That is first come first serve. Let's take an example of a queue. The person who stands first in the queue gets his job done first, and the person who stands last in the queue will come at the last to get his work done. The last important activity with batch processing is that when a job completes its execution, its memory is released. That means whenever a job completes its execution, whenever a job is to be processed, its memory is released, and the output for the job gets copied into an output spool for later printing or processing. Whenever it completes execution, the memory is released and the output is processed, put in an output spool for later processing or for later printing. Now let's have a look on this picture depicted over here that we'll be having number of jobs. In between there is operating system. Operating system takes these jobs as a batch, and then these batches are to be given to the CPU as an input. Now what are the advantages associated with it? The various advantages associated with it. First one is batch processing takes much of the work of the operator to the computer. That means there will be less human intervention. Most of the work is done by the computer. Second one is increases performance as new job gets started as soon as the previous job is finished without any manual intervention. So it saves time. There is no need of human intervention each and every time. As I give you the example of printing documents, you can either print them one by one by again and again giving the print command, or you can once give a print command and print all those documents without any intervention. Now the disadvantages associated with batch processing are difficult to debug the programs. That means if any error comes in between processing of these programs, it is difficult to find that error. Second one is a job could enter an infinite loop. Now what do you mean by an infinite loop? That means it will keep going on. It will not end. Now if a job will not end, the next job will not get in. That means if you are standing in a queue, if the first person who is on the queue will not complete its job, you will not get time to process your job. That means jobs will keep on pending. Now second important property related or associated with operating system is multitasking. Now what do you mean by multitasking? I can say that multitasking is the ability to handle more than one task at the same time. That means I am eating food, at the same time I am chatting with my friend, or I can say I am listening music while working. That means I am doing more than one jobs at the same time. So multitasking is one of the important properties of an operating system. That means multitasking is when multiple jobs are executed by the CPU simultaneously by switching between them. Now what do you mean by switching between them? For example, you have opened two apps on your mobile phone. For some particular period of time you are chatting with a friend. For some particular period of time you are mailing to your friend, or for some particular period of time you are doing some other thing. That means there is a concept of time sharing. For some period of time CPU gives some time to you for particular application, and for some other period of time it is giving time to some other particular period of application. Now the important activities related with multitasking are: user gives instructions to the operating system or to programs directly and receives an immediate response. Second one is operating system handles multitasking in the way it can handle multiple operations, executes multiple programs at a time. Last one is multitasking operating systems are also known as time sharing systems. As I already told you, it is a variant of time sharing operating systems. Time sharing means your CPU is sharing time so that response can be increased, efficiency of the system can be increased. Nowadays we are all using Android phones. These are multitask phones. Multitask means we can do number of jobs at the same time. You are listening to the music, at the same time you are chatting with a friend on the Facebook, at the same time you are chatting with another friend on WhatsApp. So you are doing multiple jobs on a single processor. Now let's have a look on this picture. On the left hand side you can see various applications. You have Word, you have Mail, you have web browser. These are all interacting with the operating system at the same time. Now let's have a definition of time sharing operating system. What do you mean by time sharing operating system? Time sharing operating system uses the concept of CPU scheduling and multi-programming to provide each user with a small portion of time shared CPU. That means we have a single processor, and this processor is shared in a timely manner with all these applications. Now we have another important attribute or property, that is multi-programming. Basically, multi-programming is a form of parallel processing. Now what do you mean by parallel processing? Parallel processing means several programs are run at same time on a uniprocessor. We don't have multiple processors. There is no concept of multiple processors here. We don't have multiple processors. We will be having a single processor. Single processor, or we can say uniprocessor. In a uniprocessor, whenever we run many programs at the same time, this is known as multi-program. You can see the picture over here. We can have number of jobs in the memory. These number of jobs can be executed at the same time by the operating system. So we can say that when two or more programs reside in memory at the same time, it is referred to as multi-programming. Now what is the benefit of this multi-programming? It increases CPU utilization by organizing jobs so that CPU has always one to execute. That means that CPU will never remain idle. We can utilize, whenever you have number of programs in the memory, we can have always one to execute. Now the various activities related to multi-programming are: operating system keeps several jobs in memory at a time. Several jobs are kept in the memory. This set of jobs is a subset of the jobs kept in the job pool. Third one is operating system picks and begins to execute one of the jobs in the memory. Multi-programming operating systems monitor the state of all active programs. That means all those programs which are active, that means running, operating system keeps track of that. And it also keeps track of the system resources using memory management programs to ensure that CPU is never idle. So basically, the whole and sole concept of multi-programming is that we always try to utilize the CPU. CPU should never remain idle. The advantage of multi-programming is high and efficient CPU utilization. User feels free that many programs are allotted CPU almost simultaneously. Now I am happy that I am doing multi-programming. It gives me an illusion that actually this does not happen. There is no concept of basically one by one. First one program is executed, then another program is executed. But multi-programming concept gives me an illusion that all programs are running simultaneously. Now the disadvantage is that CPU scheduling is required. We have to schedule the CPU in order to achieve multi-programming, and to accommodate many jobs in memory, memory management is required. Whenever we have utilized the memory, for that memory management is required. Another important activity that is related with operating system is interactivity. If you remember in the first class, I told you an operating system acts as a bridge between a user and the hardware. That means if there is interactivity between the user and the system, then only they will be able to communicate. For example, I am teaching you over here. If I am able to make you understand, then I can say that interactivity is good. If I'll be speaking in Chinese or some other language, you people will not be able to understand. Same wise, an operating system provides us a GUI, that is graphical user interface, through which we can communicate with the system. So we can say that interactivity refers to the ability of the users to interact with the computer system. Now the activities related with interactivity are: provides the user an interface with the system. Now this property of an operating system provides me an interface so that I can interact with the system. It manages input devices, that is your keyboard. It manages output devices, that is your monitor. And the response time of the operating system needs to be short. Now what do you mean by this? For example, I am pressing a key ABC and it is not shown on the monitor within 5 seconds or 10 seconds. So that means the response time of the operating system is not good. If whenever I am submitting something, you should give me an immediate response of that. Now another important attribute that is related with operating system is real-time systems. Now what do you mean by a real-time system? Basically, real-time systems are usually dedicated embedded systems. Dedicated means particularly meant for a particular thing. For example, we have weather monitoring system or flight management system. Now weather monitoring system is dedicated to monitor weather related things, and we have flight management system. That flight management system is dedicated for that particular task. Basically, another example can be of sensors. From sensors we read data, or I can give an example of flight management system. Flight management system reads data about flights. For example, a flight is going from Srinagar to Delhi. Whenever it is in the air, it gives all the information to the base station. Through sensors, through satellites, all the information is passed to the base station. These real-time systems should always be accurate. If the results are not accurate, or if there will be any bug in the program, it will be very catastrophic. So the important activities related with an real-time system are: operating systems typically read from and react to the center data. That means that operating system will always react or read data from sensors. The operating system must guarantee response to events. Whenever any query is raised, it must respond at that particular period of time. It must guarantee a response to ensure correct performance. Last important activity that is associated with operating system is distributed environment. A distributed environment refers to multiple independent CPUs or processors in a computer system. Basically, we are seeing that distributed systems are those systems which are located at remote locations. We have one system here at IUST, we have another system at somewhere else. We have different processors. These processors will be doing the tasks among them. That is, the operating system distributes computation logic among several physical processors. Single task is divided so that they can be processed very fast. Second important activity is related with distributed environment is that processors do not share memory. They do not share memory or a clock. That means if they share a clock, that means they are synchronous with each other. If they don't share a clock, that means these are asynchronous systems. Asynchronous system means they have different clocks. The operating system manages the communication between the processors. So it is the capability of operating systems which is managing all these things. If any queries in today's e-lecture, mail me at mtechnb@gmail.com. Thank you.